Algebra 2 is where we are. Today's date is Tuesday, April 9th. So, April 9th, 2019. We're on lesson 7-5, constructing exponential models. Again, our warm-up was basically all we're really doing here. Just all at once now. So, just again, this is a review from yesterday. And boy, I forgot those participation cards, but it will go fast. So, these will get turned in really quick. What is A? What do I call A? Quiet raised hand.
First value.
That is not a quiet raised hand. Quiet raised hand. Geo, yes.
First value.
That's the first value. Sure, I'll give it to you. First value. What is another name for him?
Start.
The start. What is another name?
The finish.
It's not the finish. That is the opposite of the start. Another name?
Beginning.
Beginning, yes. Or initial.
What are you doing?
All of these words are okay to use. That's where we start. That's where we begin. Many names. All right, so tons of people just got in. Oop, don't look at that. Yeah, so we have Andrea in, Gio in, Eva in. Was there anyone else that I'm missing? Those three. There you go. Nice throw. Okay, so what do we call with a quiet raised hand? What is this value right here called? What is this called, Fiona?
Common ratio?
There it is. Common ratio. Thank you, Fiona. And finally, I have something that has time up here. Let's just go ahead and make this note that says somewhere time is happening up here. We might have to divide that by something. You rarely have to multiply it by something unless you're doing something strange, but it's usually going to be dividing something. So I have a bunch of examples where we have to write this all out. Just as a note, when you're doing Khan Academy and you're doing powers, you generally want to have parentheses. So as soon as you go like Shift 6 or you hit the power button, start your parentheses, because otherwise your fraction is going to get messed up. All right, so quiet raised hand to read. Easy XP. Reading. Go for it, Teflon.
Wait, first one?
Example 1, yes. Thank you.
The bacterium increases its mass by 34% every 4.3 minutes. The initial mass of bacteria was 83 grams. Write a function that models its mass and lead to.
Beautiful reading. Thank you. All right, so I mean, there are 3 pieces of information. There are 3 things that I'm adding to my equation. So my first thing that I'm going to look for is the first thing. What is the first thing? Quiet raised hand. Tell me, Eva. There it is. 83 is our initial value. Everyone write it down. There's our start. Thank you, Eva. What is my common ratio? A little bit harder, but I think you can still do it, Andrea. It is indeed 1.34. These numbers right now are being multiplied, so I can do a little dot or I can do a time symbol, whatever you want to do. Thank you, Andrea. It is 1.34. All right, and this is going to be a little bit tricky, but what is my exponent going to be so that I still include that correct time interval, James? So I'm going to have t somewhere and probably that 4.3 somewhere. The power of 4.3 like that. You need a t in there as well because this is a function with respect to t. 4.3 is in the answer though, so you have that part correct. 4.3 does something up here. You gotta choose, James. Who's gonna help you out? T divided by that 4.3. Usually it's always going to be a division because we discovered this yesterday, Andrea and Teflon. We discovered this yesterday that in order for you to actually increase by that 34% every 4.3 minutes, I have to have 4.3 on the top and the bottom so that every 4.3 minutes it will happen. So yeah, just dividing that by 4.3 makes it work. That's probably a pretty bad explanation. Here's the simplest I can get. Always divide in the exponent. Always divide. It's always going to be a fraction. And as I said earlier, for Khan Academy, you will need parentheses up here. But for us, we don't care. All right, so thank you, James. Thank you, Gio. And then we are off to example 2. Another quiet raised hand to read it. Someone aside from Teflon. Eva, yeah? You want to do it? Oh. Sorry, I thought your hand was up. Andre, you can do the next one. Yes, go for example 2, please.
The population of a city loses 1/14 of its population every 3 months. If the initial population was 16,342, write a function that models the population every 10 months.
All right, this one is maybe one of the most challenging questions that I can ask you on the homework that is on Khan Academy. By the way, Eva, beautiful reading, thank you. Yeah, so losing usually means it's going to be either exponential decay or exponential growth. What do you guys think? Growth, decay? Thumbs up, thumbs down. Yeah, you guys are all on it. It is decay. It is losing things. So it's decaying more and more and more. All right, so quiet raised hand. What is my initial value? See Gio's hand. I haven't called on Chris yet today. Christopher, you want to do anything? This is a nice and easy one. What's the initial value? It's one of those 3 numbers, 1/14, 3, or 16,342. Yeah. Okay, Gio, go for it.
16,000.
Yeah, that 16,342 is our initial population. It says, it even uses that word initial. So again, initial, we wrote down initial in our notes, hopefully. All right, and then I'm going to multiply that by something. This is the hardest part because it's not 1/14. I'll give you that hint. If you think it's 1/14, that's decreasing by way too much. 1/14 is a tiny sliver. 1/100th is a really, really tiny sliver, so 1/14 is still a sliver. 1/2 is like a bigger chunk. Fiona, yeah.
0.86.
Ooh, so you would be rounding by doing that. Can you keep it as a fraction?
13, 14.
There it is. 13/14. 13/14ths. Because you're losing 1/14 from 1. You're always starting at 1. You either add to 1 or subtract from 1. This 1/14 is being lost, so you subtract that from 1. 1 is the same thing as 14/14. Don't know how to write 14s. And then I'm going to subtract 1/14, and that gives me 13/14ths. Nod our heads in agreement. All right. And finally, our power here. After I give Fiona your XP, our power is going to be what? And we're not using T, we're using M, so be careful. Yeah, Gio? There it is, M divided by 3. You're always going to be using division. Thank you, Gio. And our last problem before we can go off on our own to the homework. Another reader, Andrea.
In the fall, the number of blooming flowers decreases by 14% every 5.6 days. But there were 345 blooming flowers to begin with. Write a function that models the number of blooming flowers every 8 days.
Beautiful reading again. We have some really good readers in here. All right, so from here, I need to do something. Tell me what to write. Quiet raised hand. James, yeah.
345.
You are indeed correct, 345. Thank you, James. That is our initial value. Chris, I would love for you to jump in if possible. You want to try? You want to do the exponent, and someone else can do the common ratio? Is that cool, Chris? Chris? We'll do this fraction for you, but we're gonna wait for you to do the power up here. So I'm gonna give you some time to prepare yourself. So look at example 2 to see what we did for our exponent. Look at example 1 to see what we did for our exponent, and then we'll figure out the common ratio as a class. All right. So before Chris participates, can someone else help us figure out how to incorporate that 14% for our common ratio? I see only one hand, 2 hands, 3 hands. Eva, go for it. You have to be careful because it says decreases. by 1.14. So 1.14 would be, or by 14%, sorry. But decreasing by 14% means it should be less than 1.
0.86.
Yes, there it is, 0.86. 0.86, to get 0.86, we turn 14% into a decimal, which is 0.14, and then we just subtract that from 1. 1 minus 0.14, and that equals 0.86. Thank you, Eva. So that's going to be 0.86, and this is where Chris is going to save us. This is going to be to the power of, Chris? It is indeed d divided by 5.6. Oh, that's not how you write a 6, Mr. Sindel. There it is, 5.6. Perfect, Chris. Thank you. That is it. That's our 3 examples. I didn't do every single type of problem, but those are the harder ones. Ask me questions. Yes.
I'll get my headphones.
Yes, you can go get your headphones.
Gio, when you come back, can we get mine? Or my desk?
Please, is there a please in there?
Yeah, please.
All right. For your summaries, you can have a very simple line. You can say that that first number is the starting amount. You could say something along the lines of, to get the common ratio, always subtract or add to 1. So this would be a cool thing to write in your summaries. In your summary, you could say your common ratio, CR, is 1 plus or minus the percent. You're always adding or subtracting to the percent or the ratio or the fraction. Or a fraction. That would be a cool thing. Did anyone even do their summaries? You guys packed up way too quick. Maybe you're just on it. I guess we'll find out later. All right, I'm going to go ahead and put the assignment up.